In this video, we are going to study about the step 6 curing of concrete. So, before going into the curing, you need to know what is the role of water in the concrete. So, we know that concrete is nothing but cement plus aggregates and water. Cement, which is added, reacts with water and forms a paste and hardens and forms concrete along with the aggregate. So the particle compounds, that is both compounds C3S, C2S, C3A and C4AF, are going to react with water and they are going to form certain compounds at the end. So this reaction is what we call as hydration. Okay. So as you know, this hydration is not a process that happens in a particular instant of time. It is not a process that happens suddenly. It takes time, it takes months to completely hydrate. So this hydration is not a sudden movement action, sudden momentary action. So whatever the water you have added is responsible for the hydration of cement. So the more the hydration is, the more gel or the more the end product is going to be formed. We know that the product that comes after the hydration of the cement compound is CSH gel, which hardens and forms a solid mass. Okay, so as hydration is going on, as the hydration process is going on, as more and more cement gets hydrated, more and more this gel is going to be formed. Okay, so now you know that hydration requires water. If there is no sufficient amount of water, the cement is not going to get hydrated properly, and mean CSH gel is not going to be formed in the required amount. That is, the concrete is not going to achieve its strength, or cement is not going to achieve its strength properly, right? So water has a very major role that influences the hydration of cement and thereby influences the strength of the concrete. So as I told you earlier, whatever the water by cement ratio you had adopted, in that 0.23 is the amount of water that you need for the hydration. So cement requires a water by cement ratio of 0.23 for hydration for the chemical reactions, and a water by cement ratio of 0.15 to fill the voids and the pores inside the concrete. Okay, thereby you need a total of 0.23 plus 0.15, which gives a 0.38 of water by cement ratio. So this is the optimum water by cement ratio that you need to adopt in the mix design. So the water by cement ratio that you need to adopt is 0.38. So that is the amount of water that you have added for the concrete for the hydration purpose. So now this is the sufficient amount of water by cement ratio or water for the hydration. So now what happens when a portion of the water is being lost? Some water that you have added is lost. Yes, the hydration process is not going to be carried out properly to the full extent. Therefore, CSH gel is not going to be formed, and therefore, the concrete is not going to achieve its full strength. So, we have an issue here because the water that you have added indeed is actually being lost. So, how the water that you have added is being lost? Yes, first thing is the environmental conditions. Maybe the season is something like summer, so the out temperatures are very high. Therefore, the water that you have added to the concrete is being lost due to the temperature surrounding it. And the second one is, we know that this hydration process is an exothermic reaction. Heat is going to be generated in the chemical reactions, and we call that heat as heat of hydration. So because of the heat of hydration, the member itself is going to get heated from the inside. So whatever the water you have added is going to get evaporated. Just like this, we have a pressure cooker which is hot, and you pour some water onto this pressure cooker. What happens? As this pressure cooker is very hot, what happens? The water is going to evaporate. Just like pan, we have a pan which is put on the stove which is hot. You put some water on that. What happens? Because of that heat, the water is going to evaporate. So this is also the same thing. Okay, so now you need to do something. You cannot let this water that you have added to escape from the member, to go away from the member, to leave the member. You should do something, right? So whatever you are doing to control that rate and extent of moisture loss, water loss. So whatever you are doing to control the rate and extent of moisture loss from the concrete during cement hydration is what we call as curing. సో ఆ వాటర్ పోకుండా ఏదైతే నువ్వు చేస్తున్నావో, ఏదైతే జాగ్రత్తలు నువ్వు తీసుకుంటున్నావో దాన్ని మనం క్యూరింగ్ అంటామన్నమాట. So we know that we have a general case where we say mostly the curing. Curing is seen everywhere, right? One of the method that you come across is when you cast a column, what do you do is after removing the formwork, jute bags are put around that concrete and every day you are going to water it. Okay, so this is a manner of preventing the moisture loss from the concrete. Okay, that is one of the method. We are going to see some curing methods. Okay, so that is a routine example. Okay, that is the practical type of curing that is mostly adopted. We use jute bags, we put them around the column, and we are going to water it every day so that water inside the concrete is not going to be evaporated. Okay, it do not allow the concrete water to leave the concrete surface. These are the four methods of curing. First one is water curing, membrane curing, application of heat, and miscellaneous curing. We are going to see each and every one in detail. So the first one is curing of concrete with water. So this is what we do in the lab. When you are casting cubes and testing in the compression testing machine, you need to prepare samples. And to use those samples, you use this kind of curing. Of course, this is one of a kind. As you can see here, water curing can be done in the following four ways. That is immersion, ponding, spraying or fogging, and next wet covering. These are the four ways in which water curing can be done. In this first way of water curing, that is immersion, we are going to put the specimen completely immersed in the water. We have a curing tank, and in that curing tank you are going to put that concrete member or the concrete specimen immersed into it as being shown in this image. This is immersion, and this image is showing you the spraying type of water curing. So the water is going to be sprayed. This image shows you the spraying type of hand curing. So the water is going to be sprayed. Of course, you people may have come across this. See, the water through the pipe is made to splash or hit the surface of the curing. And this is also spraying and water wet covering. So what we are going to do is we are going to use these jute cloth, and you are going to spread it and you are going to wet that covering. And even this is for slab, right? And for column, what we are going to do is you are going to put the jute bag around the column and you are going to water it. Okay, so these are the different types of hand curings. And the second one is membrane curing, curing of concrete by membrane curing. So as I told you, the water by cement ratio, what we have adopted here, water by cement ratio 0.38, is sufficient for the cement to completely hydrate. Okay, so what you need to do is, you just need to avoid the loss of water from the concrete, right? So what we are going to do is, we are going to use curing compounds. So in this method, the curing compounds are sprayed on the concrete surface, and what happens is, after they dry, they form an impermeable membrane on the concrete surface, and thereby avoids the loss of water. So as you can see in this image, this is a curing compound that is sprayed on the concrete surface, and this concrete curing compound hardens and forms an impermeable layer on the top of this concrete, and the water that is inside this concrete, it cannot escape from this surface. This graph here helps us to understand the relation between the duration of curing and the strength it achieved at 180 days, 6 months. So as I told you, the curing is a method of preventing the loss of water from the concrete. So when you do the curing for more duration, what happens is, you are controlling the loss of moisture for a larger amount of time. That implies there is no chance of water being escaped, right? So when you cure it for just 3 days, at the end of 180 days, the concrete is going to be achieving around 70 to 65 to 70% of its strength. And if it is cured for 7 days, it is going to achieve around 70% of its complete strength. If it is cured for 14 days, it is going to achieve around maybe 85%, right? 85% of its strength, final strength. And if it is cured for 28 days, it is going to be achieving around 90% of its compressive strength. And if it is continuously in moist, what happens is, at the end of 180 days, yes, it is going to achieve its 100% strength. And if it is completely left in the air, what happens is, it is going to achieve only 40% of its strength. So as you can see, the duration of curing is actually influencing the compressive strength that this member is going to achieve. So that is the reason you have to cure. If you are not curing a concrete column or a beam or a slab, the hydration is not going to be happening properly, because water is being lost, and the concrete is not going to achieve its full strength. So if you do not cure, if it is just left in air, it is going to get only 40% of its strength at the end of 180 days. But if you continuously cure it, it is going to achieve 100% of its strength at the end of 180 days. So it is important that you actually do the curing for the required amount of time. And moreover, the other important thing is, the curing increases the durability, improves the durability. That is, curing actually decreases the permeability of concrete. Curing decreases the permeability of concrete, thereby increases the durability. So as you can see, on x-axis of this graph, it is curing period, and y-axis, it is permeability coefficient. So this is minus, guys, 10 to the minus 7, minus 8, minus 9. Therefore, see, as you can see, as the curing period increases, the coefficient of permeability is actually decreasing, right? So that implies that the concrete is become more and more impermeable. As curing period is increasing, it is becoming more and more dense, more and more less porous. Okay, the coefficient of permeability is decreasing, therefore, it is becoming impermeable. The third one is curing of concrete by application of heat. So, this is another method in which you actually you actually subject this concrete member to a higher temperature. So what happens here is, when you subject this concrete to a higher temperature, it actually accelerates the hydration process, resulting in faster development of strength. So what we are doing is, by application of heat externally, you are actually increasing the rate of hydration. Thereby, it hydration process is done at a faster phase. Okay, and the concrete is going to achieve its strength quickly. Okay, so as I told you earlier, if you apply heat, there is a chance of water coming out of the concrete member, right? If you heat the concrete member externally, the water that is present actually inside the concrete comes out. But in here, in this method of application of heat, what we do is we use steam. We do not directly expose this concrete member to fire or something like that. What we do is we put this concrete member in the steam, is being subjected to steam, just like in your pressure cooker. When you cook your rice in the cooker, the rice is being cooked with the steam, right? So in the same way we are going to heat the concrete by using steam. So thereby, by using steam for heating the member, the water is not going to be coming out from the concrete, because steam has moisture itself, right? So what happens is, the concrete is going to be wet, the concrete is going to be wet, and at the same time, concrete is going to be heated. And this is done in the following four ways: steam curing at ordinary pressure, steam curing at high temperature, steam curing by infrared radiation, curing by infrared radiation, and electric curing. So, in the first way, what we do is we use these tarpaulins or thick polythene sheets, and we are going to cover this, and we are going to send steam into it. So, this is a concrete beam. This is a concrete beam which you are trying to cure, or the concrete member that you wanted to cure. And we have a polythene sheets or tarpaulins. You are going to spread them over that concrete member, and you are going to send hot steam. So this is steam curing at ordinary pressure. So the pressure that is acting on this concrete is the atmospheric pressure. Okay, so as you can see, the graph here helps you to understand the age of curing and the strength it achieves. Of course, it depends on the temperature of the steam, right? If the temperature of the steam is around 46 degrees centigrade, this is the graph that you are going to see. That is the graph that you are going to get with age of curing, age with the time of curing and the strength ratio. And the second one is steam curing with high pressure. So what we are going to do is, we are not going to just simply send the steam to cure. You are going to apply pressure on the concrete member. So this is achieved by using a closed chamber. Actually, this type of curing can actually make the concrete to develop its 28 days strength in just one day. For example, if you take M20 grade of concrete, it is going to achieve 20 Newton per mm square at 28 days. 28 days ki దానికి వచ్చే compressive strength ఎంత అంటే 20 Newton per mm square. But instead of waiting for 28 days, if you adopt this high pressure steam curing, you are going to get that 20 Newton per mm square of compressive strength just in one day. So this method of curing helps us to achieve the compressive strength of the concrete in a very less duration of time. And moreover, there is an advantage with this type of curing. That is, the curing, if you adopt this type of curing, the concrete is going to become higher resistant to sulfate attack. It is going to become more resistant to sulfate attack. It is not going to become weak because of sulfates, and moreover it is going to be resisting freezing and thawing action, and the shrinkage in the concrete is going to be less. And usually the temperature at which the steam is present is 175 degrees, and the pressure at which the steam is supplied is 8.5 kg per centimeter square. These are the chambers in which you put the concrete members to subject the concrete members to steam at high temperatures. So we cannot just use some polythene sheets, right? So you are going to put in this closed chamber, and this right side image shows the cover to it. You are going to cover it, and you are going to supply the heat at the particular temperature, and the proper steam pressure is going to be maintained. And these are the chambers. See here, these are the deep beams or the girders, concrete beams, reinforced concrete beams, which are being steam cured. We have the third type of curing in this, that is curing by infrared radiation. So we are going to use infrared radiation to actually cure this concrete instead of steam. And moreover, this has been proved to achieve the strength of the concrete more rapidly than the steam curing, and that of steam curing at ordinary pressure. So we have seen the first one, in which steam curing at ordinary pressure. So if we adopt that case, what the thing is happening is the ultimate strength is going to be decreased in that steam curing at ordinary pressure. So when you adopt this curing by infrared radiation, that disadvantage is going to be gone. So you are going to achieve proper ultimate strength of concrete, and at the same time the hydration of cement is going to be carried out quickly, and the concrete is going to achieve its strength quicker, and the temperature that is maintained usually is 90 degrees centigrade. Electrical curing. So in this electrical curing, we are going to use two electrodes, and these electrodes are either buried or applied to the surface of the concrete, and we are going to allow the alternating current to pass between these two electrodes. As you can see, this is an electrode and this is an electrode. The current is allowed to pass between these two electrodes, so the current is going to pass through the concrete. In that process, what happens is this is going to be heated and it is going to be cured. This is what we call electrical curing. So we have seen water curing, membrane curing, and application of heat. Now let me see this miscellaneous type of curing. So in one of these miscellaneous methods of curing, we use calcium chloride. So calcium chloride is nothing but a salt. So generally salts absorb water or moisture from the environment. Maybe you have seen that. See, for example, in your house, see, observe this salt. When you put in a beaker, when you put in a tin, when you do not put that lid, what happens? If you expose this salt to the air, the salt is going to absorb the water or the moisture from the air, and it is going to become damp like solids. Okay, so we can make use of this calcium chloride. So what we are going to do is we are going to put this salt calcium chloride on the surface of this concrete. So since this calcium chloride is a salt and it likes moisture, it is going to absorb the moisture from the atmosphere and retain it at the surface. So now the salt is going to be present on the concrete surface with the absorbed moisture from the atmosphere. You are not going to add anything extra, water or anything, right? It is going to absorb the water from the moisture, and it is going to maintain that moisture on the surface of the concrete, just like jute bags, right? So this prevents actually the loss of water from the concrete. And farm work indeed helps us in controlling the loss of moisture. It prevents escaping of moisture from the concrete, especially in beams and columns. So keeping the formwork intact and sealing the joints with wax or any other sealing compounds prevents the evaporation of moisture from the concrete. So these are the four methods of curing of concrete. So in this video we have learned what is curing and what is the necessity of curing and what are the different methods of curing. In the next class we are going to see the seventh step, that is finishing of concrete.